Howdy, folks. So we are going to prove lines are parallel today. You're going to use those special angle pairs that we've talked about last week to help us do this. So let's kind of talk about some things for a moment here. So last week, or before today, we said if we had parallel lines, then special angle pairs are either congruent or supplementary, right? Well, what would the converse of that statement be? So if you remember from last chapter, the converse is when you flip the order. So Q implies P. So remember, the second part's going to come first. So if we have special angle pairs that are complementary or congruent, then lines are parallel. So that's what's going to happen today. Today we're going to be given the angles, and then we need to decide if it's enough information to prove lines are parallel. Okay? That's kind of our big goal idea today. So we have some reasons why as to how lines can be parallel. So the first one is the corresponding angles converse. So if we have corresponding angles that are congruent, then we have lines that are parallel. So let's pick an example. Let's say we have angle 2 and 6. Those are corresponding, right? So if angle 2 is congruent to angle 6, that's not a 6. Oh no. Then what lines are parallel, folks? You would say L, remember these vertical bars mean parallel to M. There we go. So if you have corresponding angles that are congruent, we have parallel lines. All right. Alternate interior angles converse. If we have alternate interior angles that are congruent, then lines are parallel. So let's pick a pair. Let's do 3 and 5. If angle 3 is congruent to angle 5, then what lines are parallel? L and M. Beautiful. So if we have alternate interior angles that are congruent, we have parallel lines. Similarly, if we have alternate exterior angles that are congruent, we also have parallel lines. That would be like 1 and 7. So if angle 1 is congruent to angle 7, then line L is parallel to M. And then as always, our odd man out here is our consecutive interior angles. And if we have consecutive interior angles that are, what you guys, supplementary, then we have lines that are parallel. So in our picture, that would be what? Like 4 and 5? So 4 and 5 add to 180, the lines are parallel. Let's write that down. If angle 4 plus angle 5 equals 180, then lines are parallel. So L is parallel to M. Now it seemed like a lot of writing, but it's good for us to do that. So now we're just going to practice on this next part. We just have a big picture, right? And they're going to give us a situation, and if we have to decide if that's enough information to say lines are parallel. Okay. So here we go. The first one, angle 2 and angle 4 are congruent. We have parallel lines, so we got to decide. Is there anything special about 2 and 4? And I hope you're thinking yes, they're corresponding, so that would be our converse. Corresponding. And which lines are parallel? So which 2 are parallel because of that? That would be C is parallel to D. Those 2 lines are parallel. All right, our next one. Angle 5 is congruent to angle 10. So we have to decide, is there anything special about those 2 angles? Yes, they're alternate interior. So that's our converse because they're equal. And now which lines are parallel because of that? I hope you're thinking A and B. 6 plus 10 equals 180. Is that anything special to us? I hope you're thinking yes, because those are consecutive interior angles. So now which lines are parallel? You should be thinking A and B. Correct. 1 and 14. Yep, those are special too. Those are our alternate exterior. Alternate exterior, right? So which lines are parallel? That would be A and B again. 14 and 15 add to 180. Is that special? Sure is. Those are consecutive interior angles. So which lines are parallel? C and D. $11 and 16. Are those special to us? You're right, they are. They're vertical. But do vertical angles prove lines parallel? Nope. So we're going to say none. No lines are parallel because vertical angles don't prove that. Don't prove lines parallel. Nope, vertical angles is a no-go. Okay, let's see here. 4 and 15. 4, 15. Are those special? Yep. Alternate exterior. So which lines are parallel? A and B. Perfect. Okay, why don't you pause the video? There's 4 left, right? 1, 2, 3, 4. Try these 4 and see how they go. Go. So now I'll kind of just speed through these ones. Did you pause it? I hope you did. I really hope you tried these on your own. Nothing would make my heart happier than you trying these on your own. For H, you should have had C parallel to D because those are corresponding. On I, 9 and 13, if we look real quick at those are just a linear pair, so no lines are parallel because linear pairs don't prove parallel lines. 2 and 7 for the next one on J would be C is parallel to D. C, parallel to D, because they're alternate interior. And then 6 and 11, we have nothing special to name those. There's no transversal connecting them. They're just 2 random angles, so none. There's nothing special. Okay, super. Now we're going to throw in a little bit of algebra. We want to find the value of x so that these lines are parallel. And then we have to state the converse we use. So first let's decide, what kind of angles do we have here? These would be alternate interior, so that would be the converse. So we'll say converse. Alternate interior angles. And now we gotta think, our alternate interior angles, do you want them to be congruent or supplementary? And I hope you're thinking congruent, so set them equal to each other. Add over that 23. And divide out. You should get a whole number of 16. Beautiful. So one more for good luck. Same idea. We want to find the value of x, which makes our line A and B parallel. So we have to decide what kind of angles are these. Figure out what converse we're using. Hopefully you're thinking consecutive interior angles. Yep. Now we want these to be congruent or supplementary. We want these guys to add to 180. Supplementary. Yep. Combine your like terms. Subtract over. Divide out 19. And then, because you guys are so good at proofs now, we're going to do 2 more for funsies, all right? We're going to do 2 more proofs. So, you guys know how this goes. We're pros at this now. Give yourself your columns here, statements, and our reasons. Okay, so let's see here. We're given angle 1 is congruent to angle 2, and we want to prove that line L is parallel to line M. Okay, we got it. So, start with your givens. Now we can think here. What do we know about 2 and 3? They're vertical, right? So we know that they are congruent. Vertical angles. And now if we look here, folks, I have 1 is congruent to 2 and 2 is congruent to 3. So now what 2 angles are equal? 1 and 3, by our favorite property, the transitive property. And now we're done. I mean, we have one more step, I suppose. We'll finish it off. L is parallel to M, because what kind of angles are 1 and 3? They're corresponding, and they're equal, so it'd be our corresponding angles converse to prove those lines parallel. Woohoo! That was fun. That was a lot of fun. And actually, we will not do the last one because we never talked about one of the reasons. So, thank you for watching. Hopefully you're being good. I hope you had a great weekend. I'll see you tomorrow, and we will discuss more on this information. Toodaloo.